So first mechanical properties we are going to study that elasticity. So let me explain about what is elasticity. A liquid or gas adapts itself to the shape of its container, but a solid has a shape of its own. Suppose we are taking a solid and which tends to pressure. So if we are giving a load with a solid, that solid will change its dimension. Change its dimension, but the resulting deformation will disappear upon unloading. This tendency of a deformed solid to seek its original dimension upon uploading is described the property of elasticity. In simple word, we are explaining the elasticity, that is, loading a solid will change its dimension, but the resulting deformation will disappear upon unloading. This tendency of a deformed solid to seek its original dimension is called elasticity. And every metal has their own elastic limit. And the elasticity requires a discussion of the concept of stress and strain, and this called modulus of elasticity, and the mathematically it is determined as the elastic or Young's modulus or elasticity is equal to stress by strain. You are already studying what is stress and what is strain. We know that the stress is load per unit area and the strain is defined as change in length and the original length when before the deformation of the measurement and after the deformation. This is called original length. So the elasticity is equal to stress by strain, that is denoted as capital E. The next one is your plasticity of a material. So what is a plasticity of a material? Plasticity is a property of a material by which it may be permanently deformed when it has been subjected to an externally applied load to exceed the elastic limit. We know that every material has an elastic limit or has a own elastic limit. The plasticity is a permanently deformed when it has been subjected to an external applied force. When we are applying a force into a material, it is exit to an permanently deformation and it has been subjected to an externally applied load. It is called the plasticity of a material. And the mechanism of the plastic deformation is different in crystalline materials and amorphous material. Those are the both material. One is your crystalline materials and another one is your amorphous material. In your crystalline materials, it is undergo plastic deformation as the result of slip along with a definite plane. It is all about plasticity properties of a material. Next, we are going for the toughness of a material. What is the toughness? Toughness, that is the ability of the material to absorb energy during plastic deformation up to fracture. It means when toughness refers to the ability of a material to withstand bending or the application of shear stress. We know that what is bending and what is shear stress in your strength of material topic. And the toughness is the ability to withstand bending or the application of shear stress without fracture. Like your example, copper is extremely tough but cast iron is not. So it is the difference between copper and cast iron, that copper has the maximum toughness and the cast iron is the minimum toughness. For the static situation, toughness may be understood from the result of a tensile stress and tensile strain test. So it is all about the toughness of a material. Next is your resilience. What is the resilience property of a material? So resilience is know that. So what is resilience? It is the capacity of a material to absorb energy when it is elastically deformed and then uploading to have this energy recovered. It means resilience is closely related to toughness. It is the capacity of a material to absorb energy when it is elastically deformed and then upon unloading to have this energy is recovered. So resilience is usually measured by determining the rebound of a pendulum or your ball after a single impact. It represents the ratio of energy given on recovery from deformation to energy required and to produce the deformation. So it is called the resilience property of a mechanical material. Next is your tensile strength. In your simple word, any kind of pull stress is called tensile strength. We are pulling any kind of material, it is called tensile stress, or the strength is applied to that material is called tensile strength. So it is also a mechanical properties of a material. In a tensile test, the ratio of the maximum load to original cross-sectional area is called tensile strength. It is commonly taken a basis of working stress for brittle material. So the ultimate tensile strength refers to the force needed to the fracture material. When we are giving any kind of force, any kind of tensile force to a fracture material, the stress is acting on that material is called tensile strength. And the tensile strength value is commonly taken as a basis for fixing the working stress, especially in brittle material. So next is your yield strength, and this is a line diagram of a yield strength where we are putting one line that is your stress, that is denoting your stress, and putting another line that is denoted as your strain, and this is the yield point. What does that mean, the yield point? And here the yield strength. In the yield point, the accordingly strength is called yield strength. But what is the yield point? When material are subjected to a tensile force, they stretch or elongate as the stress increases. The point where the stretch suddenly increases is the yield strength. The yield point is known as when the point where the stress is suddenly increases, the material increases its yield strength, and the point is called yield point. So the yield strength of a material represents the strength below which the deformation is almost entirely elastic. Next is your impact strength. Impact strength. What is impact strength? The capacity of a material to resist or absorb shock energy before it fractures is called its impact load. It is complex properties of toughness and strength of a material. So impact strength is a complex characteristics or complex properties which takes into account both toughness and strength of material. It consists of both toughness and the strength of a material. It is the capacity of a material to resist or absorb shock energy. When we are giving any kind of shock or any kind of shock stress to a material, it is called the impact strength. Means we are giving the sudden load or we are giving a sudden stress. So it is called impact stress. Impact strength depends upon the structure of a material fully. It is sensitive to rate of loading and to the temperature as well as the stress result. It is highly sensitive of a material, that is the impact stress is highly sensitive of loading, and it is highly temperature as well as the stress also ranges accordingly. It is called the impact strength of a material.